me to introduce Rashid Bansal. Rashid Bansal is a senior software engineer at Tesla in Fremont, California. Did I get that right? All right. Uh, and an AI researcher. His work focuses on reliable large language model, LLM applications, with publications on hallucination mitigation and benchmarking in real world systems. He holds a master's in computer science degree with a focus on AI and machine learning. The title of his presentation is Mitigating Hallucinations in Chatbots Powered by LLMs. Take it away, Rashid. You're on mute. You're on mute. So unmute yourself.
Hey, thank you, Professor. Are you able to see my screen?
Yes.
Okay, perfect. Hey, good evening, good afternoon, good morning, everyone, as per your time zones. I am Rishabh Bansal. I work as a senior software engineer as the professor informed. Today, I'm gonna present you my research work on mitigating hallucinations in chatbots powered by LLMs. We will go in depth in the given time and try to understand what are hallucinations and what are LLMs and what not. All these new terms which we hear everywhere around every time. We will slowly go around and see what are these things and how we can stop them and how we can uh, improve our performance of AI. So let's go on to the agenda for today. So the agenda is we will talk about research objectives, what are the research backgrounds, and what are the methodologies and findings, and we will end with conclusion. So I would like to start with a fact. So that is a really interesting fact I found. Like if ChatGPT reads all its training data out loud at a normal speaking speed, it would take over 500,000 years nonstop. So this you can just imagine how much data it is trained on, and so on other models as well. So very interesting fact. And going forward with the presentation. So my presentation will have following things. We will first understand what are hallucinations, and then we will understand what are LLMs and why are they so prone to this word, and what are different types of hallucinations, and finally how we can mitigate them and reduce them. If not, we can stop them. So let's talk about hallucinations. In technical terms, hallucinations are outputs that are fluent and confident, but factually incorrect or fabricated. What makes them dangerous isn't just its inaccuracy. Uh, it's it is its presentation because the model generates sentences that are grammatically perfect, contextually relevant, and delivered with high confidence. We often don't question them. We just take it as is. For example, if an LLM invents a citation or misstates a legal policy, it still sounds authoritative. That combination, high fluency, high confidence, and low factuality, is what make hallucinations so risky. User trust it user We trust it because it sounds right. We don't try to question it back, and we think because it's been trained on so many data, it must be correct, but that's not always correct. So before going forward, I would like to talk about what are LLMs actually. uh, we talk about hallucinations, we talk about LLMs, we are using AI, but how does all of this fit in a picture? What are LLMs? So, uh, an LLM is a neural network trained on massive text corpora, books, Wikipedia, code repositories. These are the data points which we talk about when we say that when ChatGPT starts reading out aloud of all the data it's trained on, these are the text corporas, books which it reads and gets trained on. And internally, it uses transformer architecture, which applies attention mechanism to understand relationships between words. But here's the key. The model doesn't know facts. It's not a database. It's not a database. It is just a trained model. It's a prediction engine. Given the word so far, it predicts the most probable next word. This predictive ability, scalable to billions of parameters, is why LLMs feel so intelligent. But also, that is why they hallucinate because they have so many training data. It feels like confident, and even if it is the next word is low probability, it feels this must be correct, which is wrong. And prediction is not always equal to truth. and it's not actually anyways equal to truth. So let's talk about how LLMs predict, first of all. This is a very simple example. Uh, if you say, like, ask, the capital of France is blank, the model will assign probabilities. It will think internally, like Paris, 92%, Lyon, 5%, Rome, 3%. Obviously, Paris has highest probability, which is 92%. It picks Paris, which is correct. But what if you ask, what's the best capital? That's a curveball for the AI. There's no ground truth. There cannot be any one capital which is best. It is very subjective question. Then, but the model is still forced to answer. It is forced to predict the next word. So it might generate something arbitrary. That sounds right. It might, if our chatbot is saving some memory or our chat history, it might check what we are talking about, and if anywhere we have talked about capitals, it might pick that data and it might try to link this question to your previous chat with the chatbots. If not, it will just try to find out some corpora or some training in which it was being used, which means there's no clear truth and there is risks for hallucinations. Uh, this shows how LLMs know so much. They have statistically encoded massive amounts of data, but when faced with ambiguous or unspecified prompts, they'll generate something plausible, not necessarily factual. That's where hallucinations creep in. What are the different types of hallucinations? To fight the enemy, first we need to know what the enemy is, and different types of techniques to fight with different types of enemies. So here are the three following broadly classified hallucination types. One is factual errors. The model gets the facts wrong, like saying maternity leave is 90 days when the law says otherwise. So if you are in a company and your chatbot, you ask a chatbot, say, what is the maternity leave for me? It doesn't know if you are talking about which company, is it talking about some state law, it is talking about federal law, but it tries to find out some answer and it comes up with the arbitrary number 90 paid leaves, which might be a factually wrong answer. So it might cause lawsuits or some very bad reputation for the chatbots. Next is fabrications. The model invents something entirely, like, for example, citing a law that doesn't even exist or fabricating a source. This is very common example in research. People who are researchers here might see that they are getting citations or resources or references which are not even existent on web. They are just being generated by AI because it can generate a reference and tell you, okay, this is the reference of this source, and this is what it says. But if you try to dig it up, you will find some of the references might not even exist on the web. And then misalignment. The third is misalignment. The model misunderstands intent. If you ask about maternity leave, but it responds with information about dental insurance, it's misaligned because that word might be mentioned inside dental insurance or somewhere, but it doesn't know the exact context which you want to know the information for. Understanding these categories helps us design different mitigation strategies. Not all hallucinations are the same, as I told earlier. And I want to inform you guys before we go forward that these hallucinations are not only when we are talking to ChatGPT or Google Gemini, but these also happen when we are trying to develop chatbots. So when we try to develop chatbots, we use APIs from these learned models. We need to be very careful how we develop the prompt and how we are communicating with the APIs of the models, which the already learned models, so that we show the user very less hallucinated data and hallucinated answers. So it can be all of the techniques which we're going to talk for in next couple of minutes can be applied in both the places, even your personal as well as your professional life. So let's go forward and talk about what are the methodologies in which we can reduce or mitigate the hallucinations. So, as Professor Justin Sherwell was informing us in earlier, prompt engineering is becoming very, very important. So, hallucinations don't have one fix; they require layered strategies. We'll go in depth with one by one in all the techniques. Prompt engineering is designing inputs carefully to reduce ambiguity, confidence rating and absenteeism, having the model hold back when unsure, fine tuning, training the model with domain specific data, retrieval augmentation, which is very commonly known as RAGs, means connecting the model to the external database for grounding, and fact checking is verifying outputs as it says. Uh, each solves part of the problem, but alone, none can solve the whole hallucination problem. Let's see how. So let's talk about prompt engineering. Uh, as seen on the screen, what is a bad prompt? Tell me about maternity leave. No information, nothing. It will just say, pick some information from some random source and give you an answer. It is vague and it invites speculation. But what can be a good prompt? Role assignment shapes the tone. It you can tell you are an HR assistant. Then knowledge constraint anchors the response. You can say only use 2024 or whatever the latest HR handbook is that tells, okay, you have to look in this information. Focus. Uh, context focus narrows the scope. Like summarize maternity leave policy. Don't look in any other place. Don't look in dental. Don't look in any other thing. Just look in the HR handbook, which says summarize maternity leave policy. And the safety, which we earlier talked about absenteeism, if unclear, say not available. This is a mix of two approaches. That is the most important because if you don't tell the bot, if not clear, or if you don't tell that in the prompt, it will try to generate. But if you tell that if it's unclear, do not say not available, then it gets a chance and it might say that it's not available. But it will still try to compare the probabilities, but your not available probability might be on higher end. This does not
5
eliminate.
minutes before Q&A.
Okay, thank you. Going forward, fine tuning. Fine tuning means taking a base LLM and training it further on domain data. For example, if you want a medical chatbot, you fine tune it with verified clinical data and case studies. This updates the model's parameters so it speaks in domain appropriate language, reduces hallucinations. But again, fine tuning is super expensive. And if the knowledge changes, like let's say the new medical regulations change, we need to retrain the whole model, which is very, very expensive and it makes it very less flexible. And for fast changing domains, it might not be the right solution. Then we talk about retrieval augmentation. It's very different from fine tuning. It's like connecting an external database with the bot. Imagine the user asking about maternity leave. The retriever fetches the relevant section from the HR handbook and gives it to the chatbot, saying, adding in the query that this is your information. Just give an English answer or a language, an answer in language, which tells this in a simple human language. Then LLM generates an answer grounded in that text. RAG is very powerful for dynamic knowledge like HR policies, news, or financial data because you just update the database, not the model. But it has a weakness too. If the database is updated or manipulated, the model produces incorrect results anyways. So RAG is flexible but not bulletproof. Let's go on to the next, which is fact checking. Uh, Fact checking adds a verification layer. After LLM generates an answer, it's compared against a trusted source. If it doesn't match, it's flagged or blocked. Fact checkers can be automated, or it can be a smaller LLMs. Like one of your bot can answer the question which is asked between the chat, and then the other one can check against the context of the question and what the chat is being going on and check if they produced the right answer. So in this way it can be automatic, but as my previous presenter told, it also needs to include sometimes a human in loop. Fact checkers can also be like essential to sign off before the user sees any answer. So let's say if you are designing an AI CRM tool, when a ticket is generated and the AI knows that, okay, this is the most common answer which I have to generate, we should not just send the email as is. We should first generate a draft for human eyes. Once the human eyes skip through it, quickly reviews it, they can click on the send button. This is what human loop in simple language means. So we always have a human taking the final decision if the answer is correct or it needs more amend or needs to go as is. Industry and academia are actively researching on these techniques. As you know, research is going on very high speed. Current solutions include domain-specific LLMs that are smaller and cheaper, and hybrid pipelines that combine both RAGs and fine-tuning and fact-checking. The benefits are very tangible in this research. Like there are very few compliance risks, lower operational cost, since fewer queries escalate to humans, and higher trust from users. All in all, to close, hallucinations are very normal to LLMs, but we can mitigate them. The key is layering, prompts, confidence, fine tuning, retrieval, and fact checking from all of the aspects, and they all work together. And as a user, we should practice healthy skepticism, question the answer, look for citations, and prefer grounded responses. That's how we can make LLMs not only powerful, but also trustworthy. Thank you. And now I open the stage for questions.
Please post your questions in the chat or um, obviously verbalize them at this point.
All right, we have a question. What architectural or training data changes could most effectively reduce hallucinations in LLMs without limiting creativity?
Yeah, so when you are designing an RAG system, I'm assuming that you are designing a RAG system for when you are giving the training data or fine tuning. First of all, fine tuning is pretty expensive. And if your documents change, you need to change the database and you need to retrain it. So retraining itself becomes one heck of a job. But when you are doing as a RAG system, when it's just an additional database, as I informed earlier, be make sure your database is very relevant to your bot. For example, if it's an HR bot, make sure you have HR database policies. If it is if it is an insurance bot, just make sure that you have all the insurance policies and what are the common responses of the inspectors, or what are the policies of the company, so that the bot can look in the right place rather than creating answers of itself. So the data has to be very specific to the domain, and do not try to create a bot which does everything. Try to create bots for specific purposes and ground them to the reality and train them just based on the domain for which the bot is made.
All right, another question we have is when you supply a prompt, LM gives us the answer based on ranking. Let us say the next prompt that I supplied, does the LM have context of those ranks? And if so, why does it hallucinate as it already has a context of what the user is asking for? Good question.
Oh, very good question. So this question uh, is like, when you design a bot, not all bots are designed same. This brings me to my next research as well. In that, which I am doing, is like not all the bots have a previous memory. So sometimes the bots are designed like that some bots have last five questions and answers, or sometimes it's always a new question for the bot and everything goes as a new question to the LLM. So in that case, sometimes if the bot is not designed properly, and if it doesn't have its local memory, or if it is not saving what you are talking to RAGs or your source, sometimes the memory can be very limited, right? So in that case, you do not have the bot doesn't have the whole context of your conversation, and it only takes every question as a new thing. So it depends on how the bot has been designed and how much resources the developer has, so that it can have a huge memory for their bot.
And the follow up to that one was why design a bot that doesn't have a memory of what the user is talking about?
It's not right to design a bot without a memory, but there can be some use cases, or there can be resource limit on you, because sometimes the chat can go so long that it acquires a lot of memory, and it might cause issues with other forms of uh, networking and all. But it is very common in a professional world to stop or limit the memory usage per session, so that it doesn't continue asking. And sometimes even the older context becomes a problem for the new responses, so you don't want the too old context and talking to you now. Like if you talked about something couple of days back, you do not want them to talk about the same thing or have the context of the same thing. So it needs to have a newer sessions and limited memory of the old data talked about.
Okay. And when building agentic AIs, how can you benchmark to reduce heavy cost of LLMs?
Benchmark the cost of LLMs as in for memory. Can you please repeat the question?
Sure. When building agentic AIs, how
Okay.
can you benchmark to reduce heavy cost of LLMs?
Yeah. So we need to figure out first of all what is causing this cost. uh, if you are using LLMs, if you are using LLMs, sometimes the number of queries is costly. Then sometimes the context window is costly. What I mean by context window is how many tokens you can pass in an API at one moment. Let's say you can pass just 10,000 words. By tokens, I mean words. So you can pass 10,000 words, but there are always upgrades available. As we talked about in last as we talked about this thing in the last question, sending all the information to LLM is also becomes very expensive. So every API has a context window. You can send only limited number of words to the query and it can answer based on that. So currently, I think we are using 10,000 tokens for an API, and sometimes that also becomes very less. So we need to upgrade our plan. So all of these things need to be kept in mind before designing an LLM system, that where do you want to compromise on? Do you want to compromise on memory? Do you want to compromise on your training data? Do you want to compromise on your networking, or do you want to compromise on the context window? All of these all together will help you benchmark your bot and AI usage.
Okay. And then now we're almost close to 80% accuracy in the development of software with the right prompts and articulation. Are there any initiatives for AI models to have the self-learning bots? And what are the constraints beyond investment in AI?
Oh, that's a really good question. Uh,
Wasn't mine. It was
even
David. It was cigars.
so yeah, so even if it is 80% developed, I would still say um, it still needs to learn a lot of context. When you are designing something from start, it's easy, but the context is lost when, like, let's say when you are already have an application or a repository and you try to put more AI into it so that it learns the context. Sometimes business problems are not properly handled by AI, and there are multiple problems in which AI can fail. So still more and more research is required in how we can handle the business context. Software engineers are still required to interpret stuff from business and try to explain it to bots. Like there are some edge cases always, looking forward, there's a huge chances that AI can handle themselves and generate its own, just asking questions to the business partners. But still, I would say even if 80% code is correct, we still require a lot of development for them to understand the business problem and give the right solution.
All right. I
I think
think
we
that's
have
all the
time for
questions we
one
have.
more. We have time for one more question, and then we've got to go to a coffee break. And before I forget, Rishab, can you put in your contact information in the chat so folks
Yes.
can keep in touch with you?